talk was originally called something else, and then I saw Substack had a really cool title, How Not to Write Big Apps, so I just had to say, How to Write Big Apps. And the reason is Node.js apps are getting bigger. And that's happening because we're starting to do real stuff with them. So we're a consulting company, we build stuff for clients, and the stuff they're asking us to build is getting bigger and bigger and bigger over time. And my talk is not about cool code, right? At this conference, you're seeing a lot of cool code and streams and all sorts of really cool stuff. But a lot of the stuff we have to worry about is the boring code. E-commerce integrations, calculating sales tax, stuff like that. And that's a meat of a lot of the client apps that we have to build. So really, we had to solve this problem. We had to figure out how to do it. And the interesting questions, where you get to do cool stuff, how you scale up these apps. There's a whole bunch of answers, and you've seen various ways to do it today. Being stateless, having loads of little processes. There's whole loads of really cool stuff you can do at V8, like turning off garbage collection. But it doesn't actually help you scale business apps. Because the real question you have to answer is, how do you scale up your brain as a developer? How do you build something that has lots and lots of complex business rules? So let's take a look at a business class, right? How do we write a class for cars? So here's a very simple JavaScript class that describes a car. So I didn't tell you at the start, there's going to be a little bit of audience participation in this talk. And the front row starting to look a little bit uncomfortable. Okay, so there's a couple of different ways that you can write classes in JavaScript. That's one of the cool things about JavaScript. So we're going to vote on the different ways. So if you like this way of writing your JavaScript classes, put up your hands now. Not particularly popular. Okay, how about this way? People like to write prototypes? Maybe. Okay, what about functional way? Who likes that? Max likes it. Yay. So that's telling us something interesting. First of all, the reason JavaScript is really cool is you don't have to pick any of these ways. But I'm going to ask, which one should we use? And if you didn't vote for one of my ways of doing it, think of your own way in your own head. Okay, how do you decide which class structure you're going to use? Okay, so this is the point where we play a little game. Okay? I'd like you all to stand up, please. Thank you. Everybody? Cool. Okay. So, the first question. Is this a car? Cool. Okay, so this is the way the game works. If you think I'm showing you a picture of a car, you stay standing. If it's not a car, sit down and stay sitting down. Okay, let's see what happens. Okay, is this a car? Yay. Is this a car? Yeah. What about this? Is this a car? Okay, cool. What about this? Is this a car? Yeah, I know it's called a land speeder. It's also a hover car. Is this a car? Yeah. No, the rules are you stay sitting. Is this a car? Sit down, sit down. This is a painting. Okay, so which should we use? Okay, classical, prototypical, functional. Yeah, I did rob them out of Douglas Crockford's book, and I know there's a fourth one, but I've forgotten which it is. Exactly. We don't use any of them. They're all wrong. This is the reason they're all wrong. You can find properties of all of those cars that don't fit. My favorite one is the Model T. Okay, so if you were trying to describe how fast a car can go from 0 to 60, and it's like 5.2 seconds for the Ferrari Testarossa, it's not even a question you can ask about a Model T Ford. It only goes 45 miles an hour. So the question doesn't even make sense. So this is what's wrong here, okay? The way that we do programming, object-oriented programming, is to use something called platonic forms. We imagine that there are ideal things, ideal ways of describing things in the world. and they have a specific set of properties that you can identify and enumerate. So an example is a triangle, right? It's got a whole bunch of properties that everybody would say a triangle has. So here's another thought experiment. Picture in your mind the idea of a triangle, the ideal triangle. It turns out, however, that Plato was wrong, and these ideal things don't exist. You've just thought of one, but I'm telling you, it doesn't exist. And the guy who proved Plato wrong was this guy, George Berkeley, the same guy from the university, and he was actually Irish, and he taught down the road in Trinity College about 300 years ago. And he invented a whole load of cool stuff. In particular, and this proves that he was a really cool philosopher, 300 years ago, he invented this. Okay, so most of his writing is, we are, all of us, simulations in God's head. Okay, so this guy can think really, really deeply. And he observed, there is no mental image of an ideal triangle. You all thought of triangles in your head. You know what? They were specific triangles. They weren't general. You can't think of the general form of a triangle. It's always specific. That's why classes suck. That's why most other languages suck, and JavaScript rules because it doesn't have classes. It has objects, and objects are good. They're not as bad as classes. They still have the same problems. And how do we know they have problems? Because we have to use lots of hacks to make our programs work in the real world for real business. And these hacks are inheritance, refactoring. Yeah, refactoring is a hack. It is. Architecture is a hack. We are forcing the real world into these ideal forms. Encapsulation, schemas, polymorphism, unit testing. Unit testing is a hack. You're not matching the real world properly. Dependencies. All of these things that we have to deal with day to day as a developer, it's telling you something. They are code smells in and of themselves. So something is wrong with this idea that you should model a car, a business object. But I think there's something that all those cars have in common. You can still drive them. Even the Lego one, right? You just pick it up and push it along. All those cars can be driven. And I think when we're writing business logic, the thing to observe is that it's not about what the objects are or the classes are, it's what they do that counts. And this is the type of things that I'm talking about, the stuff that happens in your app. Registering a new user, placing an order, calling an external service, all those things that you have to do, the stuff that the business analysts and the clients want to see, the important stuff. Okay, so we've got Node.js, we've got JavaScript. How do we solve this problem? We just make it as simple as it can possibly be. The stuff that happens is a JavaScript function. JSON goes into it, and JSON comes out of it, and it's done. It's the simplest possible model that you can have for this idea of stuff that happens. There's one other piece that we need. How do you find the right stuff to do? Use pattern matching. And this is an idea that I robbed from Erlang. You take a look at the JSON that's going in, and you do a pattern match against it, and you execute the function. So here's an example. I have two things that can happen. I can save products, and I can load them. So I don't care about most of the fields, the name and the price and all that sort of stuff. But I care that the thing that I'm working with is a product, and I care that what I want to do is either save it or load it. And I match those patterns against functions, and I run them. So define your business logic this way. Define it using these actions or commands, stuff that happens. So why should you do this? What's the payoff? Okay, so obviously, easy testing, because you can just verify the JSON that's going in and out. Even cooler, you get a distributed system for free. So think about it. You've decomposed your business logic into commands, JSON in and JSON out. It's really, really easy to take those and put them onto other servers. So you can use Fleet or Seaport or anything like that. If you remember from Max Ogden's talk, where he distributed his system into a whole bunch of different servers, Well, each of those could be running a command. It's really, really easy to decompose a single app into a whole bunch of different apps, and you don't have to decide in advance which commands have to run on different servers. You just build it all in the same app to begin with. The other nice thing is that all of these commands need to know nothing about each other. You're just sending JSON in and JSON out. You don't have to know how the database is implemented or anything like that. You just say, save this product. You don't have to know how sales tax is implemented. You just say, give it to me. And you know, if you're doing sales tax in the US, you have to worry about which state you're in. If you're doing sales tax in Ireland, you've got to worry about which sales tax rate applies. So you can make sure that there's no dependencies that you have to worry about in these commands. The other thing you get is plugins. And again, for free. You just put a bunch of commands together that have the same theme, and you're done. The nice thing about this, when you're writing business logic code, this boring code, is that it's an easy way to organize the logic. Here's a lump of code that deals with sales. Here's a lump of code that deals with user permissions. When somebody new comes onto the project, it's really easy to point them to the right place. Take a look at this plugin that looks after users, and you're done. You also get middleware-style layering. So it's one of the really cool things about the Connect module is you can build middleware that does all sorts of interesting stuff with the HTTP request as it comes in. You can do the same thing here. So if I have a plugin that talks to a database, I can add a caching layer on top of it. My calling code knows nothing. It doesn't know that it's being cached. All it knows is there's load and save commands. They're being intercepted by the caching module, it's talking to a cache, and then maybe going to the database. It's all completely transparent. The other thing you can do once you've decomposed your business logic into these commands is you can do stuff like you can trace them, you can log them, you can throttle them, you can add a permissions layer, you can handle special cases. They all become really, really easy. It's important to note, this isn't about writing ordinary code like this. This is to solve the problem of boring code and how you handle business logic. Which brings us to this point, right? It's easy to document because you, again, have a well-defined set of properties that are handled by certain functions. All you have to specify is the type of JSON you expect and the type that is going to get sent out. And although we don't need to document a lot of our small JavaScript processes, we do need to document the business logic in some way. So this isn't just ideas, right? There's code behind this. Part of what we're doing today is open sourcing this. So there's a module that implements these ideas called Seneca. There seems to be a philosophy theme here today, which I'm really happy about. It's pretty cool. I called it Seneca because he was a Stoic philosopher, and you have to be Stoic to write business logic code. Speaking of code, so this is what the code looks like. Okay, so let's define a command to add two numbers together. And we're saying that if the role is math and the command is sum, then we want to add them together. So I'm using seneca.add to specify a mapping from a particular bit of JSON to a particular function. And then I call seneca.act to make stuff happen. And you can see that it's pattern matching. It looked for role equals math, command equals sum, and it didn't care about the rest of them. And it added together left and right, and you were done. It's pretty much that simple. That's all you have to do. The inside of these functions is the stuff that calls your cool code that can do anything. This just sets up the mapping. It can get kind of inconvenient. It's a named argument style, but it can kind of get verbose and inconvenient. So we have a little convenience function called pin that creates a magic API for you. So in this case, I'm pinning the role equals math. I'm taking all the commands, and that gives me math.sum as kind of a magic API. This is important when you have 50 business rules to worry about, and it reduces the code volume that you have to write. So let's look at what a plugin looks like. In this case, I have a math plugin, and I want to do sums, and I want to do products. And this follows this really, really common convention with Node now, which is that your module is just a function. So you can see I'm calling seneca.use. It's analogous to connect.news or express.use. And I'm just passing in one function. So that function could be a module in your own system. And all it does is add a couple of functions. There's no real API to learn. Of course, it's nice to expose things over HTTP. So in your callback to Seneca, you can provide a connect middleware function. And because these often take the same form, we have a little bit of abbreviation here where you can say, map these specific commands to a little HTTP API. So what I'm saying here is that I want to be able to say /API/sum left and right, /API/product left and right. And I just want to make it really easy and convenient to do that. Okay, let's build a distributed system. So on the client side, I'm going to rip out the definition of what math.product is. And instead, I'm going to say, use a transport plugin. And every time an action is requested, where the role is math, the command is product, go out on the network and look for it somewhere. And you can see my client code stays exactly the same. So if I wrote something, and a month later, I need to scale it up, I just delete the code lines, and I put in a transport, and I'm done. On the server side, all I need to do, and that's using this code, okay, which exposes my HTTP API. I just have to say, this is transportable now, and I need the connect.json parser because I'm going to be getting JSON in. And that gives you a distributed system. And you can put this little server behind Nginx or whatever you like and scale it up. Or, much better, register it with Seaport, and then it's discoverable. So the other piece of convenience that we provide is an active record-ish style API for data, which just makes your life more convenient. Again, this is all commands. There's no magic here. There's a save command and a load command and a delete one and a query one. And you just write plugins that handle these commands. And we have ones for in-memory databases and Mongo and MySQL or whatever. Because they're commands and because it's pattern matching, you could do some interesting stuff. For example, in the first month of building your minimum viable product, everything goes into Mongo. Suddenly you're successful and you need to scale up. Those purchase transactions you were storing in Mongo unsafely, they need to go in an ACID database. So you match the patterns that are saving transactions and you put them in MySQL instead. Your user profiles stay in Mongo. Also, because you need to scale, you take your user sessions and you put them into Redis. The API stays the same. So a couple of other things about the module. It's actually 18 months old. We've been using it for quite a while. It has really detailed tracing to help you understand what's going on in terms of the business rules, because tracing why some user is unable to log in despite the fact that they purchased is really important. It has very nice error messages. So I'm really, really keen on having nice error messages from whatever module you're using so that you can debug and understand what's going on when you're trying to put things together. And it has a REPL. So where's D-Shaw? He was over there somewhere. It's got a REPL, right, which is really, really important. It means that you can telnet or netcat or whatever into a running process, figure out what's going on. Call this API directly. And it is in use in production in a bunch of different places, most of which, unfortunately, I can't speak about. But needless to say, I would be sued if this went down. So we're really, really happy with it as a tool. The last question, why did we build it? We built it to solve our own problem. Okay, so people come to us and ask us to build minimum viable products, the first version of their idea. The problem is not when it fails, the problem is when it's successful and has to be scaled up. And it's a real pain if we have to rewrite the thing. So Seneca allows us to scale up the code, to scale up the business logic, and keep going with the client when they're successful. Thanks very much.